Okay, we just experienced our first technical difficulty, but here we go. Plug the numbers in, 9 halves plus 9, boom, minus, I just simplified a little bit. You're probably going to use your Inspire, you get 20 and 5/6, which as a decimal is 20.83, and the 3 is going to repeat. Okay, so I hope you're kind of picking this up as I'm putting it down. We're going to do, let me see, I have one more example, and then we'll do one that has a nice little trick to it to finish up. So we got 2 examples yet, and what I think I'll do with this one is exactly what I do in class. I'm going to throw it up on the board, kind of get you started a little bit, and then I'll tell you to pause the video so you can work it out on your own and see how you're doing, and then we'll come back. I mean, for me it'll be real time, but I'll tell you to pause so you can stop, pause your video and you can work on it. So one last look at this problem. I got 20 and 5/6, everything here, so you can get a nice look at it before I erase it, okay? All right, next problem. Let's find the area between y equals the square root of x and its nice partner again. We're going to stick with the parabolas again. Y equals x squared. So 2 very basic functions, 2 very simple ones, not a whole lot going on. Again, we're going to start out here. Everybody knows what y equals x squared looks like. It's your parabola. What about y equals the square root of x? Square root of x, since we're referring to this as a function, and a function must pass the vertical line test, Algebra 1, square root of x is a sideways parabola. But it's only sideways if we look at it as plus or minus root x. So if you just see root x, we're only considering the positive portion of that. So the positive portion kind of is looking like this. The negative would be down here. Typically they're viewed as 2 separate functions. So we're only going to look at the positive one. And there's that teardrop shape again, right there. So I'm going to stop right here. And I'm going to pause this. I'm not going to pause. I'm just going to tell you to pause. See if you can't get this started, and then so pause your video for just a few seconds. See if you can't figure it out yourself, and then restart it, and we'll continue. So here I am. I'm going to put together my integral. So as I look at that, I can tell that root x is on top. So again, top minus bottom. Square root of x is on top, minus x squared. There's my dx, the differential. Now, I got to find this point. Well, everybody knows what that point's going to be. That's 0, 0. How am I going to solve this? Set them equal to each other. X squared equals the square root of x. I think just by looking at this, I don't even think we need to do anything here. I think we can tell that this is 0, and probably a lot of you are going to say, Mr. Lascanin, that has to be 1. Because if it's any other number, what other number is the same whether you're squaring it or taking the square root? So it's got to be 1. Okay? So we're going from 0 to 1. Alright? Now, where are you going to make a mistake in this problem? Right here. That's the hard part of the integral. Because remember, that square root of x, that's the same as x to the 1/2 power. Okay? It's the same thing. So, x to the 1/2, you're going to add 1, x to the 1/2. 1/2 plus 2 halves, x to the 3 halves. Remember, it's going to be over 3 halves, so that's going to be 2/3. Minus x cubed over 3, evaluate from 0 to 1. Folks, they don't get easier to plug numbers in. 0 goes away because 0 times everything here is 0. So all we have to do is take care of the 1. So that's going to be 2/3 minus 1/3, and box it up. Box it up. Okay? Everybody getting it? If only Kyle were here to erase the board, it would be just like school, but instead I'm going to have to erase it myself. Okay? I hope you got that problem. That one wasn't too bad. Alright, this last problem of the video is going to show you a little trick that we can use to make our lives a little bit easier sometimes when we're working some of these problems. So this problem, I'm going to say here, this problem uses symmetry. Okay, so we're going to find the area bounded by y equals x squared minus 4, and I'm keeping this one really nice, negative x squared plus 4. And when we make this graph, Blair? When we make this graph, you'll see what's going on here. So, there's our graph. X squared minus 4. Here's our parabola again. Sticking with nice easy functions again. So we're sticking with some nice parabolas. So x squared minus 4. That's a parabola that holds water, right? Minus 4 tells us we're down 4. How we shift graphs around. So 1, 2, 3, 4, boom. So we're going to go like this. Negative x squared plus 4 means, this is going to be the same exact thing, folks. Plus 4 means we're starting up here. The vertex is up here. But now we're going to intersect right there. And we're upside down. And we are after all that area in there. So I'm going to shade it a little bit differently this time because there's that side and then there's this side. So I hope you see that those two pieces are exactly the same. So when I set this integral up, there's going to be two ways to proceed. One way is the way we've been doing it. The other way is a little bit of a shortcut, and it's going to use symmetry. So let's put this together like we've always done. Top minus bottom. What's the top function? The upside down one, negative x squared plus 4. Just for clarity, I'm going to put that in a parenthesis. Because now we're going to subtract the bottom function, which is x squared minus 4. Where are you going to make your mistake? You're going to forget to take that negative through there. So you're looking ahead, it's going to be minus x squared plus 4. So I hope you're kind of looking ahead of what's going on there. I'm going to highlight that again because that's the place where you make your mistake. Now, what's different with using symmetry are these numbers here. Because we're going to be able to do this one of two ways. So in order to figure this out, we have to get this value and that value, the points of intersection of the two graphs. So to get those 2 points of intersection, again, x squared minus 4 equals negative x squared plus 4. Bring the x squared over, we're going to get 2x squared. Bring the 4 over, we're going to get 2x squared minus 8 equals 0. Pop out a 2. The 2 is going to divide out. And there's x squared minus 4. And again, factoring fun while in quarantine, what do we get here? X minus 2 times x plus 2. So what are my x coordinates? Plus and minus 2. So here's minus 2 and there's plus 2. Those are the points of intersection. So if you're going to continue with the method we've done all day today in this video, we're going to go from -2 to 2. But the point of this example was to use symmetry. That's why I shaded the left side of this blue and the right side black. We can simplify. So I want you to think about this for a second. What is the easiest number to plug in at the end when you want to evaluate an integral? The easiest number to plug in is always 0. So we don't have to go from -2 to 2. We can do this. Everything's the same. But instead of going from -2 to 2, we can go from 0 to 2. Why am I using 0? Because 0 is the center of this symmetrical, kind of weird looking shape here. It's not really a circle, because it's like two parabolas connected. So we can go from 0 to 2. Now if we're going to go from 0 to 2, what do we have to do to that region to get the whole thing? Well, because it's symmetrical, all we have to do is double it. So we can put a 2 in front. So what's different here? The only thing that's different between these two methods using symmetry is this and right here. We're doubling this area. Now what's the advantage of doing this? You're plugging in a 0. You get to plug in a 0, and that makes life easier. So I'm going to kind of just stop right there, or I'm not going to stop. I want you to pause and see if you can't get this going. All right? And I don't care which way you do this. I don't care if you never use symmetry. But what I'm saying is that if you do use symmetry, it kind of makes things a little bit easier at the end. So you should probably pause your video and try to work this through on your own, and then resume and pick it right back up. Okay? Because I'm just going to keep going and get this done. So let's simplify this. We have 2 times the integral from 0 to 2. So if I take that negative through there, I'm going to have -x squared plus 4 minus x squared minus 4. Okay? So let's see what happens here. Well, I think I copied down, that should have been a minus, excuse me, that should have been a minus. So that should be a plus. I'm sorry about that if you worked through and you copied it wrong. I'm sorry, I made a mistake there. So -x squared minus x squared, that's -2x squared. 4 plus 4 is 8. Don't forget the 2 out front. We haven't done an integral yet. So let's take this integral. X squared, that's going to be x cubed over 3. So this is going to be 2x cubed over 3 plus 8x from 0 to 2. And don't forget, this whole thing has to be what? Has to be doubled. Nice. Look what happens when I plug in a 0. Boom, boom. That's going to be 0, that's going to be 0, so that wipes out. So all we have to do here is 2 times 2 cubed is 8. 8 times 2, 16 thirds. Plus 16. 2 times 16 thirds is, let's see, 32 thirds plus 32. And 3 into 32, what is this? This is 10 and 2 thirds. Plus 32, so it looks like it's going to be 32 and 10, 40 and 2 thirds? 40 and 2 thirds? Oh. Nope, nope, nope. Folks, I made another mistake, sorry. Right here, this negative has to go here. I forgot that, so that negative has to carry through. Negative right there, negative right there, negative right there, so that should be 20, that's not going to be 40 and 2 thirds. That's going to be 32 minus 10 is 22, so what's that going to be? 21 and a third. 21 and a third. 21 and a third. Sorry about that. 2 mistakes and 1 problem. I'm just really nervous being on camera, you know. 21 and a third. 21 and a third checks out. It's what I did. It's what I have earlier. So, I apologize for those 2 mistakes, but there we go. Find the area between 2 curves. Top minus bottom, left to right. Calculate your integral. Be careful of the negatives, as you just saw, because I made 2 mistakes with negatives right there, because I'm getting hungry. It's almost supper time. So anyway, until I see you again, stay safe, relax, don't worry. You're all going to get it. It's going to be fine, and we'll talk to you later this week. See ya.